Yeah, today we'll talk about two things. First one is how we can use linear algebra for solving some examples. This is in your book. If you want, this is your book. This is it's in your book, chapter number 1. It is application 1.6. We don't have PowerPoint here. I have one PowerPoint and one from your book. Application of linear algebra, how we can use this linear algebra. So first of all, we have this PowerPoint. I will show you on how we can use the linear algebra for solving some examples. This is circuit, electrical circuit, and here you have I and V, and you have V and R. How we can solve? Find the current following in the each branch of this circuit. How we can use linear algebra solving this circuit. I know you know it. You have to use Kirchhoff, but how we can use linear algebra for this one? So we have this branch 1, branch 2, branch 3. How we can apply linear algebra in this question? First of all, here let's return back and let's make direction of loop. Direction of loop, here we have volt, volt, pivot, volt, and this is the volt. Yes, who has a question? Yes. Who asked me? Just a minute, check. What do you mean true lesson يعني? What do you mean true lesson? Yes, yes, I know. I know how we can use linear algebra for electrical, for industrial, and for you also. So you have this one. Okay, how we can use linear algebra for electrical circuit and for industrial engineering. Not for you, for all kind of engineering. Okay, here we have a loop. By the way, you said like this at high school, so it's not new. And in physics, you said something like this. So we'll make a loop. Then we will write the formulas for this loop. Okay, start with this one from here. Direction from positive to negative. Then let's write Kirchhoff. This is minus 1000. See, if you want to see the answer with me, okay, let's see here. This part, let's take I and R. So I1 with 3 ohm, 30 ohm, plus I1 with 10 ohm, plus I1 with 20. This opposite. See here. I1, 10 I1, this 10 I1, then 20 I1 minus I2. Here we have two currents. So I1 minus I2 with I2, same direction, it's positive. I1. Okay, how we can write this one again? I will explain to you. Let's take each R. And let's write for R. So for R1, this is we have 10 I1. This is for this one. Plus. Here we have 20. Okay, 20 ohm. I1 and I2 in the same direction. So I1 plus I2. Okay, because we have to close this or decrease this one. Yes, here. And I should decrease it to close this. in this way. Now, together, this I1, so it is 10, I1 positive. Here, current same direction, so plus 20, I1 positive, I2. Here we have this one, positive 30, I1 equal. Here we have, see this I1, we have one direction, detect here direction from positive to negative, from positive to negative. This is the same direction, so it is 1000 minus opposite direction minus 1000. Clear or repeat? Should clear or repeat? You know it's clear. It had to be okay. Okay, I will. This is I1. Okay. Before starting, let's go to the battery. Battery positive is positive, negative, positive, negative, positive, negative, positive, negative. Then we have direction from positive to negative. Now go to I1. I1 passes through this and this and this. So it's right for I1. I1 is 10 with I1 positive. For 20 we have I1 and I2 in the same direction. So it's right for this one. 20 I1 positive I2. For I3 we have plus 30 I1 equal. Okay, let's go with this one. See this? This direction same. So it's 1000. Okay, go with this. This is opposite. Thousand. No, I1. Here. In the same loop, Muhammad. In the same loop here is I1. Just I1. Got I3 here. It's clear for you? I1 here. I1 here. Forget now I3. Forget I2. Just we are talking about I1. It's okay? It's okay for you? You can start with anything. You can. I just explanation. You can start with 30, you can start with 10. But here I want to work like your book. Direction of loop. Good question. Usually direction of loop it's randomly, but I prefer to give you this idea. For example, here power positive, negative. This is battery. Direction of loop opposite the battery. Usually, I will write this one. Tip. Direction of loop is opposite the direction of battery. Okay, so if I have this from up to down, direction will be for I opposite. This is for volt, this is for I. Got it? Here we have two power. So you can select either same or different. It doesn't matter for me. Here it is random. Here also you have 2 powers, so it is random. But usually we are following the biggest one. Here we have the same. Here we have 1000. Here we have here 1000 and 2000. So 2000 is bigger than 1000 will be this one. Here, see this one. Here we have 2000. Here I have 1000. So 2 is bigger than 1. So direction will be opposite the biggest one. Clear? Uh, okay. Now let's go to the third one. Here I have 2000, 2000. You can select anyone. You can select this or this. Up to if we have same, you can select the same one. But this one, focus on this one. Here we have 1000. Here we have 2000. This is bigger than this. So this here is opposite. Usually, how we can select the direction. First, if you have just one battery, so directly current opposite the volt. This is the rule. If I have two, which one is the biggest? Current opposite it. Like this one. This one is bigger than this, so the current opposite than this one. And this one, 2000, 2000, so you can select any kind. No problem for this one. Clear? It's clear for you, Anna. Now let's continue. 10, see here, in the first loop number 1, this, I can write directly, see this I1. So it is 10 plus 30 I1, here current 1, then 20 I1 positive I2 equal, this is, see the volt, same direction, 1000, this is continue opposite direction, minus 1000, and it's the first formula. Is it clear? First formula is clear for you in the loop 1? Loop 1. Should I repeat or clear for you? Okay. Now another loop is this one. I2 pass through 40, 20, or 15, sorry. So here I have I2, 40 plus 15, it's 55 alone. Then see I1, it's I1, same direction. Yes, same direction. So here you can say I1 with 20, 20, I1, good. Now from loop 3, see this is up, this is up. So same direction, plus 5 I2 positive I3 equal, see the same, see the volt here, volt here is okay, this positive negative 1000, continue here, this is opposite, minus 2000. It's a clear or repeat? Let's see our book and check. Okay. Here we have 2000. This is all important. We will rearrange. So it's 15 I2, it's in direction. Then 20, 15 I2, this is I2 here. Also we have 40 I2 below. Here in this one we have I1 positive I2, see this one. We have I1 plus I2 in this one. Then 5 We have both, see the same direction. Five. I3 same, I2 same direction. Now we have here the volt. Biggest one 2000 minus 1000. Biggest one minus smallest one. Okay. Now, so biggest one 2000 minus 1000. Last one is this. It's right equation for this. Here we have 5. See the direction for current. Same direction. So it's 5 I2 positive I3. Now for I3 we have 25 and 35. So put us I3 25 plus 35 equal same. So 2000 minus 2000 because they both are opposite. See this? Same direction, opposite direction. So 2000 minus 2000. Is it clear? Yeah. Now let's see the right here 2000 minus 2000. After that, I will refine the formulas. So I have 10 here 20. So this is equal 10 with 20. So it's 30 I1 no more 10 20 30 60 60 I1 plus 20 I2 equal plus 0 equal 0. Now here we have I1 is 20 I1 20 35 75 80 I2 equal I3 here is 5 plus 5 I3 equal 1000. Now here I1 is 0, we don't have plus 5 I2 plus here 25 35 and 5, so we have 5 40 20 65 I3 equal 0 yeah. Is correct? Is correct? Now let's see the book. 60 20 I2 0 20 80 5000 0 5 65 I3. Now as you see here, we're converting circuit theory to be like this. How we can solve this? You can solve this on augmented matrix. 60 20 0 0 20 80 5000 0 5 65 0. Then you can solve based on augmented matrix to find the values. Okay, how we can solve? You have many ways. For example, you can change this with this to get 0 directly. So we can write 60 20 0 0, then 0 5 65. Which one? 20 will be 0. You can do. We can, yeah, change the column 65 0. Then here we have 20 80 5000. So now we have this. Now we have to change this and change this. Then you can get for the value for this one. Okay. Any question about this? So you can find the values for each one based on this one. Okay. Now this is the first case how we can use linear algebra for solving. Another example for also using for circuit theory, this one we can make. For example, as we said, for example, here we have thousand, so you can select what you want. This here thousand, 2,000. So this is the biggest one. So the same direction, 2,000, 2,000. So you can select this one and you can solve. By the way, this is just random. You can select which direction up to you and solve this example. Here we have something I guess we studied at high school called Wheatstone Bridge. Also, Wheatstone Bridge you can solve the circuit theory and you can make the direction, for example, I1 or I2, I3, and this is I1. See I1 like this. And you can find the values for each one as you want. This is for first job of using replication. And here you can find the answer for this one, how we can use this one for high for source circuit theory. Now, another thing in your book is this one. With your book, this one, your book. Here, how we can use also application of linear equation in, for example, industrial. Here, for example, we have, suppose I economy consists of coal and electric power and steel sector, and output of each sector is distributed among the various sector of. So here we are talking about powers. For example, we are using power. Here they gives to me the distribution of output for or from where is this for? For example, coal came from steel, electric, and coal. Here zero. Electric came from 0.2 or 20% from steel, 0.1 from electric, 0.6 from coal. Steel came from 0.2, 0.5, 0.4. Like this question, excuse me if you see, don't be fair about this question. Just convert words to be variable. Like for example, like steel is X, electric is Y, and coal is Z, and so like this one. So see in your book, they converted, for example, coal to be B coal, then electric 0.4 BE electric, and 0.64 B steel. So just focus out, convert the words to be variable. Equal coal. So B coal here is 0.4 from B electric, 0.6 from B steel. Another one I guess you can write with me here about the so B 0.6 B coal plus 0.1 B electric plus 0.2 B steel equal electric B electric. Same thing for the third one. 0.4 B coal plus 0.5 B electric plus 0.2 B steel. Here is okay. Here is equal B steel. Okay. After that, we have B steel here and B electric here. Enter to another part. convert to another part. And return this formula to be homogeneous equations. So just take BS to another part, P to another part, and now as you see here we have homogeneous equation solved with based on augmented matrix, and you can find the values. Here see last one we have 0 0 0 0. That's mean P still is free variable. I can select any number that I want. It's a free variable. I can select any number. So this my factor here didn't depend on be still. So I can, you see, I can write the parametric vector form P power. It's B still. It's 0 4 BS or B cool. B electric is 0 8 from B still, and B still is the same. So this is the one example how I can convert anything to be linear algebra matrix and can solve as this one. Another one is for chemistry, balancing chemical equation. Also we can, I will not think, it's not in your exam, I know you didn't prefer chemistry. So it's how we can use this one here. For you, for network, for example, flu. This is for example for you, or for sometimes for civil engineering. Also they can use this one. Okay, what about you? About you is this one. About you, how we can use this one for image. For image. For example, I will show you image. See who asked me, this is not in your book, this is in your book. See, this is about determine the current loop in the figure. So this is in your book. It's 110, how we can use this one in your book and how we can solve the example in your book based on linear algebra. For you also, yes, here we are. We are using matrix or linear algebra also for something called image determinant or image recognition. How we can know the image, how we can convert each part to image. For example, let's read this question together. Linear different equation or recurrence relation. Here in this example, we are using difference equations to determine each object inside this one. And solve this one like a matrix. I want to introduce to you. This is, for example, also for more advanced, inshallah, we'll study later. They will take this image and they will make as, see with me, like this. They will make as X and Y, for example, this and Y. So you'll convert to the matrix. And then they will take each matrix here, each square here, and take the value, for example, here 1. This is, for example, 0. For example, 1. For example, 0, and so on. Then they can find the object based on this one for face recognition or image recognition. Yes, you can. This I want to enter deeply to this one. It's not my course. You can later in your courses you can see something about image recognition, and you have to study how you can convert the image to a matrix and to numbers. After that, you can enter this number to MATLAB to solve inside the MATLAB. So this is where I can find this course in my domain. Yes, you can find this one about converting image to be matrix and enter the matrix, this matrix, for example, to MATLAB to solve inside the MATLAB to find the object. And later you can use this one in artificial intelligence courses. So again, this course is important for you later for artificial intelligence or AI to for example for learning or for deep learning. Later you can study about this one in another courses. Any question about this?